All right, so in this video, I'll be covering the fundamental identities. Specifically, I'll be proving all of the fundamental identities. And it's important for you to not only memorize these identities, but also to understand where they come from, right? And how we got there. Because when you're asked to prove identities on an exam, it's going to require a step-by-step logical progression, right? So you'll have to understand how we arrive at a particular identity. And it's also going to help you in case you forget something. I don't know, you forget one of your fundamental identities. Understanding how we got there can help jog your memory, right? And you can do a quick sketch in the corner to come back with that identity. So starting things off with the reciprocal identities, well, there isn't really that much proof to this. It's just, you just have to remember that cosec theta is equal to 1 over sine theta, and sec theta is 1 over cos theta, and cot is 1 over tan theta, right? And I have a weird way of remembering it. I just know that if I have a C here, I can't have a C at the bottom here, right? And if I have an S here, I can't have an S at the bottom here. So cosec gotta be sine, not cos, right? Cosec gotta be equal to 1 over sine theta, not 1 over cos theta. And sec theta has to be 1 over cos theta, not 1 over sine theta, right? So the S gotta go with the C. And cot is just the odd one out, right? 1 over tan. Pythagorean identities. Well, they come from Pythagoras' theorem, as the name suggests. And it's important that you understand that the Pythagoras' theorem states that the square of the hypotenuse is equal to the sum of the squares of the other two sides, right? Understand the theorem in words and not as a squared is equal to b squared plus c squared, because you might confuse yourself. You might not know, okay, a is which part of the triangle. So be very careful. Understand the theory in words, right? And you also have to understand, well, remember your trig ratios, right? And there's a way for you to remember them. SOHCAHTOA, right? Sine theta is opposite over hypotenuse, right? Cos theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. All right, it's a nice mnemonic for you to remember. Based on these trig ratios, for this triangle, sine theta will be equal to opposite over hypotenuse. Opposite side is y. Hypotenuse is r. Right? Cos theta will be equal to adjacent over hypotenuse, which will be x over r. And tan theta will be equal to opposite over adjacent, which is y over x. Right? Simple. Now, what happens if I take sine theta and divide it by cos theta? I'm effectively taking y over r and dividing that by x over r. Right? So this will be equal to y over r multiplied by r over x. Right? The r's cancel out, leaving me with y over x. And y over x is clearly tan theta. Right? So you see that sine theta over cos theta is equal to tan theta. Right? That's one of the fundamental identities you have to remember. Now, let's say, let me write these back. Good. Now, let's say I square these trig ratios, right? I square both sides with this equation. I'll have sine squared theta is equal to y over r all squared, which from the laws of indices, we know that this is the same as y squared over r squared, right? Cos squared theta will be equal to x over r all squared, which is the same as x squared over r squared. Now, what happens if I decided to add sine squared theta and cos squared theta together? That'll be the same as adding y squared over r squared and x squared over r squared, right? And since we have a common denominator, we can simply just add the numerators, y squared plus x squared, and put that over the common denominator, r squared, right? I'm gonna put the x in front, x squared plus y squared all over r squared. That is sine squared theta plus cos squared theta, but we're not done. Now, let's go back to this triangle, and you'll understand why these are called the Pythagorean identities. Now, according to Pythagoras, the square of the hypotenuse r squared will be equal to x squared plus y squared, right? R squared is x squared plus y squared. And going back down here, this x squared plus y squared can be replaced with r squared. So r squared over r squared is equal to 1, right? So it means that sine squared theta plus cos squared theta is equal to 1. That's something you have to remember. Now, from this single identity, you can derive a few others, right? If I take this equation and I divide throughout by, let's say, cos squared theta, right? I'll have sine squared theta over cos squared theta plus cos squared theta over cos squared theta is equal to 1 over cos squared theta, right? Remember that sine theta over cos theta was tan theta. So sine squared theta over cos squared theta will be tan squared theta, right? That's tan squared theta plus cos squared theta over cos squared theta is 1, and that'll be equal to 1 over cos squared theta. Remember that 1 over cos was sec, right? So 1 over cos squared theta will be sec squared theta. This is another identity for you to remember, right? Now, let's say I take this same equation, and this time I decide to divide throughout by sine squared theta. I'll end up with sine squared theta over sine squared theta plus cos squared theta over sine squared theta is equal to 1 over sine squared theta. Right? So sine squared theta and sine squared theta cancel out. I have 1 plus, all right, this is cos squared theta over sine squared theta. Remember that tan theta was sine theta over cos theta, right? So squaring both sides, I'll have tan squared theta is equal to sine squared theta over cos squared theta. Now, if I upturn this side of this equation, I have to upturn this side also, right? So 1 over tan squared theta is equal to cos squared theta over sine squared theta, right? And cot was 1 over tan. Remember that. So 1 over tan squared theta will be cot squared theta. Right? So that's plus cot squared theta, and that's equal to 1 over sine squared theta, right? And 1 over sine was cosec. So 1 over sine squared theta is cosec squared theta. It's another identity to remember. To derive the identities involving complementary angles, we first must understand that complementary angles are angles whose sum is equal to 90 degrees or pi over 2 radians, right? And for this derivation, I also want you to recall that the sum of the angles in a triangle is 180 degrees or pi radians, right? So for this triangle that I have drawn here, for this triangle, theta plus alpha is equal to 90 degrees. So it means that theta and alpha are complementary angles, right? So now let's bring in our trig ratios. For now, I'm just going to erase alpha and focus on this theta. And if we're focusing on this theta, y is the opposite side, x is the adjacent side, and r is the hypotenuse, right? So we know, just a different color, we know that sine theta is equal to opposite over hypotenuse, y over r. Cos theta is equal to x over r, and tan theta is equal to y over x. Good. Now, what if our focus was on alpha? What if our focus was on alpha? If our focus was on alpha, x will be considered the opposite side, and y will be considered the adjacent side. All right? So it means that sine alpha will be x over r, opposite over hypotenuse. Cos alpha would be y over r. And tan alpha would be x over y. Since theta plus alpha is equal to 90 degrees, it means that alpha is equal to 90 degrees minus theta, right? So I'm just going to replace the alpha inside of these arguments with 90 minus theta. X over r was what? Was cos theta. So it means that sine of 90 minus theta is equal to cos theta, right? And the cos of 90 minus theta was what? Y over r. And y over r was sine theta, right? So that's equal to sine theta. And tan of 90 degrees minus theta is equal to what? X over y, right? Now we don't have anybody up here with x over y. We have tan theta being y over x, right? So the tan of 90 minus theta is simply just the flipped version of tan theta, right? So that's 1 over tan theta. Good. And this is very important for you to remember. This explains why cos of 60 degrees is equal to sine of 30 degrees. Right? Because if you put that in your calculator, you'll see that they're the same thing. Because 60 and 30 are complementary angles. Now for the identities involving compound angles. Now, a mistake that a lot of beginners make is thinking that the sine of a plus b is equal to the sine of a plus the sine of b, right? And the same thing for cos and tan. But that's not true, because the sine is a function, and the a plus b here are the contents within that function. So you can think of, well, it's actually called the argument, but you can think of sine as being a pouch, and the a plus b, which is the argument, being the content within that pouch, right? So you can't distribute the sine over the a and the b, because sine is not multiplying. It's a function, right? Remember that. So, what is sine of a plus b? All right, before I get to that derivation, I want you to remember that to find the area of a triangle when we know an angle and the length of the two sides forming that angle, we use the formula half AB sine theta, right? So in words, the area of a triangle with an angle theta is half the sine of the angle theta multiplied by the product of the length of the two sides forming the angle theta, right? So this here, just remember that. So now for the derivation, I want to consider this triangle QRJ, and right up here, there is a compound angle, right? Now, I also want you to observe that for triangle 1, which is the left half of this triangle, see that H is the adjacent side and J is the hypotenuse, right? So cos of A would be equal to H over J. And for the triangle 2 on the right, cos of B would be equal to H over R, right? Keep that in mind. You can see why just now. So now let's say we had to find the area of this triangle QRG, right? That big triangle. Now, we can use that formula, half AB sine theta, right? But in this case, it's going to be half of what? Half of the product of these two sides multiplied by the sine of the angle formed by those two sides, right? And the angle formed by those two sides will be this whole angle here. That whole angle, A plus B. Good. Now, there's another way for me to find the area of this big triangle, QRG. I can find the area of triangle 1 and add it to the area of triangle 2. Right? So, this is also equal to the area of triangle 1, which is going to be a half of what? Of HJ, half of HJ times sine A, because we're focusing on triangle 1. Right? Plus the area of triangle 2, which is going to be a half of HR multiplied by sine B. Good. So, taking this equation, I want to make sine of A plus B the subject, right? So, we can multiply throughout by 2 and divide everybody by JR, right? To isolate that sine of A plus B. So first, multiplying throughout by 2 will give me JR times the sine of A plus B is equal to HJ times the sine of A plus HR times the sine of B, right? And now I divide throughout by JR to isolate sine of A plus B. So look here, the J and the J cancel out, the R and the R cancel out. So I'm left with HR times the sine of A plus HJ times the sine of B. Right? Now, H over R, remember, H over R was cos B. Cos B times sine A plus H over J. H over J was what? Cos A times sine B. Right? And that's what the sine of A plus B is equal to. That's a compound angle formula. Have to remember that identity. All right, now from this one identity, I can derive one for the sine of A minus B, right? And I can also derive the one for cos and tan. Let's work with the sine of A minus B first. Now, if you think about it, A minus B is the same as A plus minus B, right? So we can use back this same formula up here, but we're just going to replace the B with minus B, right? So our expansion will be cos of minus B times the sine of A plus the cos of A times the sine of minus B, right? Now the cos of minus B is equal to cos B, right? And that's because cos is what we call an even function. It means that it doesn't matter what sign the argument takes, the output will be the same. Cos is an even function, right? And if you put cos of negative 60 in your calculator, you get a half. Put cos of 60, you get the same thing. See, the sign of the argument is not affecting the output. But for sine of negative b is equal to negative sine b, right? So sine is not an even function. And same thing with tan. Tan is not an even function. The tan of minus b is equal to minus the tan of b. All right, remember that. So sine of a minus b, sine of a minus b will be equal to the cos of minus b, which we know is just cos b, times the sine of a plus cos a times the sine of minus b. But we know that the sine of minus b is minus sine b. So we're multiplying by minus sine b. Right? So that'll give us the cos of b sine a minus the cos of a sine b. Right? And that's another formula that I need you to remember. Now, let's talk about the cos's now. What about the cos of a plus b? What would that be? Now, remember the identity involving complementary angles. We found that cos theta was equal to the sine of 90 minus theta, right? So cos of a plus b will be equal to the sine. If you think about this a plus b as being one big theta, cos of a plus b would be equal to the sine of 90 degrees minus that one big theta, which is a plus b. Right? And this whole thing is the argument here. Now, I'm going to distribute this minus. So that'll give me minus a minus b right here. All right. Good. Now, we can treat this 90 minus a as though it's one big angle, right? And I just have that b there. So let's call this big angle c, right? So I have the cos of a plus b is equal to the sine of c minus b, right? And now we know how to expand the sine of an angle minus another, right? This was the formula up here. But this time, instead of a, we have c, right? So that's going to be the cos of b times the sine of c minus the cos of c times the sine of b, right? Now c was 90 minus a, so let me just write that back. So the cos of b is going to be the sine of 90 minus a minus the cos of 90 minus a, right? Times the sine of b. All right, so this is what we have, right? Now we can replace this sine 90 minus A with what? Cos A. And I can replace this cos 90 minus A with what? Sine A. Right? From the complementary angle formula. Right? So just rearranging this can be the cos of A times the cos of B minus the sine of A times the sine of B. So it just looks a bit better. Right? Remember this. So what do we have to find next? Cos of A minus B. Right? The cos of A minus B. And we're going to use the same logic as we did earlier. The cos of A minus B is the same as the cos of A plus negative B. Right? So in this expansion, I'm just going to replace that B with minus B. So the cos of A minus B is equal to the cos of A times the cos of minus B. Well, we know that the cos of minus B is still going to be the cos of B, right? Cos is an even function. So the cos of B minus the sine of A multiplied by what? This is going to be minus the sine of B, right? So this will give me the cos of A times the cos of B plus the sine of A times the sine of B. And that's it right there. All right. We did sine, we did cos. We got to go to tan now. Now, remember, that tan was sine over cos, right? So the tan of A plus B will be equal to what? Sine of A plus B over the cos of A plus B, right? So I can now expand the numerator, expand the top there, using what? Using this same formula I had earlier. Sine of A plus B, right? So the sine of A plus B, we know that is going to be cos B times sine A plus cos A times sine B. And that's the expansion for the top there. Divided by, expand the bottom, cos of A plus B. And we found that cos of A plus B was the same as the cos of B. Well, let me start with A first. The cos of A times the cos of B minus the sine of A times the sine of B. Right, that was the expansion we got. Now I'm going to divide top and bottom by cos A, cos B. Right? I'm going to divide the numerator and the denominator by cos A, cos B. So I have the cos of B times the sine of A plus the cos of A times the sine of B divided by cos A, cos B all over cos A, cos B minus sine A, sine B all over cos A, cos B. So I'll have cos B sine A over cos A, cos B plus cos A sine B over cos A, cos B. All right, this whole thing here was the top. Right? And for the denominator, I have the cos A, cos B over cos A, cos B minus sine A, sine B over cos A, cos B. right? So now what's happening now? Now I can cancel out some things. Cos B and cos B cancel out, right? Cos A and cos A cancel out, right? These two cancel out also. So now I'm left with sine A over cos A, right? And I'm also left with here, I'm left with sine B over cos B. And here I have sine A over cos A and sine B over cos B, right? And we know that sine over cos is tan. So I start bringing in the tan now. Sine A over cos A is tan A plus sine B over cos B is tan B divided by, this is 1, right? Because everybody cancel out, minus sine A over cos A is tan A multiplied by sine B over cos B, which is tan B. So you see that the tan of A plus B is equal to that right there, to that expansion. All right. So we did tan A plus B. What do we have to do now? The tan of A minus B. And it's the same thing, right? Tan of A minus B is equal to the tan of A plus minus B, right? All right, so that'll be equal to the tan of A. Remember I said that tan is not an even function. It's just like sine, right? So we gotta so we gotta put that minus on the outside. So tan of minus B is minus the tan of B all over 1 minus, because of this minus here, I'll have another minus in front, minus the tan of A times the tan of B, right? And these two together is plus. Right, so I have the tan of A minus B is equal to that. All right, now we did compound angles. Now it's time to look at double angles, right? Now, the trig identities for double angles really stems from the identities for compound angles, right? Because a double angle is really just two of the same angles adding together. So the sine of 2A is actually the same as the sine of A plus A, right? And we know that the sine of A plus B is equal to the cos of B times the sine of A plus the cos of A times the sine of B, right? So you just got to replace the B with A. Replace the B with another A, right? So you're going to have this, the cos of A times the sine of A plus the cos of A times the sine of A again, right? And that's just two of the same thing adding together, right? So that's 2 cos A sine A. That's sine 2A, right? And if you had to find the sine of 3A, it's going to be the same logic. The sine of 3A will be equal to the sine of, let's say, 2A plus A. So this time, you just replace the A with 2A, and you replace this B with A, right? And you basically use the same expansion. You might have to simplify it a bit, but let's move on to cos. What is cos 2A? Now, we know that cos 2A is the same as the cos of A plus A. And we know that the cos of A plus B we had was the cos of A times the cos of B minus the sine of A times the sine of B, right? So for this one, we just got to replace this B again with A, right? And that's equal to the cos square A minus sine square A. That's cos 2A, right? That's one formula for cos 2A. But sometimes it's more convenient for you to have a formula for cos 2A that is exclusively cos, right? Or exclusively sine. Now remember, the first Pythagorean identity, sine squared theta plus cos squared theta was equal to 1, right? So from this, you know that sine squared theta would be equal to 1 minus cos squared theta, right? So now, we're going to have cos square A minus sine square A, but sine square A, we know, is going to be 1 minus cos square A. So we get cos square A and cos square A adding. So we're going to have 2 cos square A minus 1. And that's another expression for cos 2A. Right? What if we wanted one with exclusively sine? Well, we know from this formula that cos squared theta is equal to 1 minus sine squared theta. Right? So you can replace cos squared theta with 1 minus sine squared theta. Right? So cos square A will be 1 minus sine square A. So cos 2A is equal to 1 minus sine square A, right, as a substitution, minus sine square A. So it's equal to 1 minus 2 sine square A. Good. Now tan, same thing. Tan 2A is the same as tan A plus A. Right? And that's equal to tan of A plus tan of A is 2 tan A over 1 minus tan of A times tan of A, which is what? Tan square A. Now, for the identities where we take a product and convert it to a sum or difference. Now, we know that sine A plus B is equal to this over here, and sine A minus B is equal to this here, right? Now, what is sine of A plus B plus sine of A minus B? What's that equal to? Well, we're going to take this, sine of A cos B plus sine of B cos A, and add it to this here, right? Sine of A cos B minus sine of B cos A, right? And when we add them, if you take a look at this, you can see that these here are like terms. These here are also like terms, but they're subtracting, so they cancel out, right? Add these two together in blue, and we get 2 sine A cos B, right? It's the sine of A plus B plus the sine of A minus B. So switching this around, 2 sine A cos B is equal to sine A plus B plus sine A minus B. Instead of adding sine A plus B and sine A minus B, what if we subtracted them? What is sine of A plus B minus the sine of A minus B going to be equal to? Well, that's going to be equal to sine A cos B plus sine B cos A minus into sine A cos B minus sine B cos A. Right? And a minus distributes. So I have sine A cos B plus sine B cos A minus sine A cos B plus sine B cos A. Right? So look at what's happening here. These two are adding, and these two here, they're subtracting. Right? So I'm left with 2 sine B cos A. Right? So this will be equal to, or this will give me sine B cos A. Wait, let me write the one with A in front. So I'll be 2 times cos A, 2 times cos A times sine B is equal to this thing over here. Good. So those are the two identities. Now, what about cos now? Right? So if I add these two together, if I add cos A plus B and cos A minus B, I'll be effectively adding this up here to this down here. Right? And these two, the like terms, they're going to add together. And these two here, they're subtracting. So they gone out. So I'll be left with 2 cos A cos B. Right? So 2 cos A cos B is equal to the cos of A plus B plus the cos of A minus B. Well, what about cos of A plus B minus cos of A minus B? Right? Same idea. This time we're subtracting. So it's going to be cos A cos B minus sine A sine B minus into cos A cos B plus sine A sine B. Right? So I have cos A cos B minus sine A sine B minus cos A cos B minus sine A sine B. Right? So these two terms, they're like terms. Right? Both of them are negative. And these two terms here, they're also like terms, but they're canceling out each other. So I'm actually left with minus 2 sine A sine B. Right? So minus 2 sine A sine B is equal to the cos of A plus B minus the cos of A minus B. That's another one to note. All right. Now to derive these identities, let A be equal to x plus y, and let B be equal to x minus y. All right. Now take this equation, make x the subject. I have A minus y is equal to x. Let's call it equation 1. And take this equation and make x the subject also. So I'll have B plus y is equal to x. All right, let's call this equation 2. The goal is for us to find an expression for x in terms of A and B. All right, so I'm going to add these two equations together. All right, I'm going to take A minus y is equal to x and add that to B plus y is equal to x. So I'll be left with A plus B, right, minus y plus y, we know that's 0, is equal to x plus x, which is 2x, right? So 2x is equal to A plus B, therefore x is equal to A plus B over 2. All right, and note that. Now, if I wanted to find an expression for y in terms of A and B, I'll simply subtract the two equations, right? So that'll be equation 1 minus equation 2, which is going to be A minus y is equal to x minus B plus y is equal to x. All right? So when we solve this, we're going to end up with a minus b minus y is minus 2y is equal to x minus x, which is 0. So I'm left with a minus b is equal to 2y. So y would be equal to a minus b over 2. You saw earlier, I think I had a and b, but the sine of x plus y plus the sine of x minus y would be equal to, let's see which one that was. That one was going to be this one, right? So I'll end up with 2 sine x cos y, right? Now, x plus y was what? X plus y was a, right? And x minus y was b. So I can start substituting now. So that'll be the sine of a plus the sine of b is equal to 2 times the sine of x, and we know that x is equal to a plus b over 2, times the cos of y, right? And we know that y is equal to a minus b over 2. All right, so this is the first formula. All right. What about the sine of x plus y minus the sine of x minus y? That's going to be equal to, that was the one with cos and sine. So that'll be 2 cos x times sine y. All right. So this will be the sine x plus y is a minus the sine x minus y is b. All right. So that's equal to 2 times the cos, x was a plus b over 2, times sine of a minus b over 2. All right, so another one to note. Well, what about cos of x plus y plus cos of x minus y? We know that was equal to 2 times cos x times cos y, right? So cos a plus cos b is equal to 2 times the cos of a plus b over 2 times the cos of a minus b over 2. What about cos of x plus y minus the cos of x minus y? That's equal to minus 2 sine x sine y, right? So this is the cos of a minus the cos of b is equal to minus 2 times the sine of a plus b over 2 multiplied by the sine of a minus b over 2. All of our fundamental identities, I've proven them, and now let's put everything together. I have a nice summary here. So I would have divided the set of identities into 2 groups. A primary group, which will consist of the identities that you're going to have to remember, like do your best to memorize them. And then the secondary group, which would be your identities that you can sort of derive if you know the primary ones. But I would recommend that you at least memorize some of the secondary identities so you don't waste time on the exam. Right? So the identities I have highlighted in yellow are the ones that will appear on your answer sheet. That's if you're writing CAPE. So starting things off with the reciprocal identities, these are the ones you're going to have to remember. Remember that cosec goes with sine. So cosec theta is equal to 1 over sine theta. And I have a weird way of remembering it. I just know that a C goes with a S. So if by some chance you have cosec theta is equal to 1 over cos theta, that's a bit weird because the C has to go with a S. And you see the same thing here with sec theta and cos theta, an S and a C, right? And then the cot is just the odd one out. So gotta remember that. All right, now for the quotient identities. Now, these are very easy for you to mix up. Some people might say tan theta is equal to cos theta over sine theta. Don't do that. Remember that tan loves sine on top. I know it kind of sounds freaky, but it's a very nice way for you to remember that the sine goes on top when you're talking about tan. And cot, we know, is a reciprocal of tan. So cot theta is going to be the cos over the sine. And for the complementary angle, please remember that sine theta is equal to cos of 90 minus theta. And pretty much is a similar pattern for cos theta. And then tan theta is just the odd one out. And then we have the Pythagorean identity. This is the primary one. Have some more. Now the compound angle identities. Now, what I want you to remember, I want you to remember that sine sort of mixes everybody up. So once you have sine of a plus b or a sine of a minus b, you're going to have the sine and the cos's multiplying each other. So sine sort of mixes everybody up. And cos segregates, cos separates everybody. So you got the two cos's together and the two sines together. Another thing I want you to be mindful of is that with the sine, the sines are normal. Think about it that way. Sine has normal sines, and cos is just the weird one. Because when you have cos of a plus b, you're going to have cos a times cos b minus sine a times sine b. Right? So with sine, the sines are normal. With cos, the sines are weird. Now, with tan, you're just going to have to remember that there is an anomaly going on at the denominator where the sign is sort of reversed at the bottom there. For the sum to product, again, remember, sine mixes everything. You got sine and a cos multiplying each other. Sine mixes everything. Cos and sine multiplying each other here. And cos segregates. You got two cos's together and you got two sines together. All right, just remember that. Now, for your secondary identities, once you know the primary ones, you can end up with the secondary ones by performing a couple of operations. So if you know this primary Pythagorean identity, you can make cos squared theta the subject and end up with this identity. Cos squared theta is equal to 1 minus sine squared theta. You can take this identity, divide throughout by sine squared theta, and you're going to end up with this identity. 1 plus cot squared theta is equal to cosec squared theta. Divide throughout by cos squared theta, you end up with this identity. Make sine squared theta the subject, you end up with this identity. Right? So once you know this one, you're in a very good position. You can get the rest. Now, once you know the compound angle formula, sine of a plus b is equal to what I have over here. If you replace the b with the a, you can automatically end up with the double angle formula. Right? Because replacing that b with that a is effectively having 2a in there. And same thing with cos. Replace the b with the a, and you can get back the double angle formula. Once you have this formula here, sometimes they want it with exclusively cos or exclusively sine. You can replace the cos square a with 1 minus sine square a, and you end up with this identity. Replace the sine square a with 1 minus cos square a, you end up with this identity. Now, once you know your two compound angle formula for sine, these are the two equations we got. If we subtract the two equations, we end up with this identity. If we add the two equations, we end up with this identity. Same thing with cos. You got your two compound angle formula. You add the two equations, you get this identity. Subtract the two equations, you get this identity. right? So it's just a matter of you understanding how we end up with these identities. That's really going to help you remember. All right, that brings us to the end of this video. If it helped you, please show some love, leave a like. Until next time.